You can't see or feel the force causing this globe to levitate, but it's not magic, it's magnetic. To make magnets, they must first create a sand mold of the magnet shapes. They load this pattern of 4 magnet shapes into a machine that fills it with sand. They remove the pattern and smooth the surface, dimpled by the machine's lid. Then it's back inside, but this time, the machine pumps in gases to chemically harden the sand. It takes just seconds to solidify. They lift out the sand slab, revealing the impression of the magnet pattern. It's now a mold. Magnets come in many shapes and sizes, as do their molds. Now they're ready to mold the magnet shapes. They take copper, cobalt, sulfur, nickel, pure iron, aluminum, and titanium. They load all these metals into an electrical induction furnace. It generates a pulsating electromagnetic field that heats to more than 1600 degrees Celsius, melting everything into a molten soup. They pour it into the sand molds. The molds burst into flames because the gases that harden the sand are highly flammable. They slide the blazing molds to another part of the foundry and knock them to the floor. Then they bust them open with a sledgehammer to get air inside so they cool down and the gases burn off. They shovel everything into a bin and sort the metal shapes from the sand chunks using, what else? A magnet. The molded pieces react like ordinary metal. They don't yet have magnetic power. Some are shaped like rings. Threaded onto a copper pipe, they'll be used in electric motors. They place the ring-covered pipe in a much larger tube. Then they center it by packing silica sand tightly around it. The sand will hold the rings in position during the next step. They seal both ends with concrete, allowing the inner copper tube to protrude slightly. Then it's into another electrical furnace. It heats the tube full of magnet shapes until it's red hot. This primes them to accept an electromagnetic field, which will be delivered by this metal rod. They slide it down the center of the copper pipe and clamp it in place. Water keeps the pipe from melting as they deliver a low-voltage, high-current charge in a cylindrical formation, important for motor magnets. They break open the seal. The process has left the ring shapes mildly magnetized, but most importantly, it's oriented the magnetic field properly. They grind away any rough edges. At this point, all magnets are pretty useless. But this machine will empower them. It delivers an electromagnetic charge to the metal, which magnetizes it. The establishment of that weak magnetic field earlier has laid the groundwork for this moment, ensuring that the magnetization is properly oriented. Now that's some serious magnetic muscle. In their various forms, magnets continue to exert a lot of pull in our society because their invisible power helps keep so many things running.